Hi lecturer, I'm going to talk about the memory management systems comparisons in Windows and Linux, and my name is Wong Wai Kiat. So now we are looking into the similarities of both operating systems. So similarities of distributions of process address space in Windows and Linux. So the process of the virtual address in both of the operating systems are distributed in the same way. The lower part is used by the user and upper part for the kernel. The upper part points to the same kernel code. The process of the virtual address space in both of the operating systems are distributed in the same way. The lower part is used by the user and the upper part for the kernel. The upper part point to the same kernel code. And next, we are talking about the differences. So, the, in Windows operating system, the cluster demand paging is used to fetch clock algorithm and pages for the page replacement. Where there is a need of using page, the page will be brought to the memory in cluster demands paging, and approximately of 1 to 8 pages of a cluster will be brought by Windows depends on the state of the system. So now we are looking into the 5 types of page faults. The first one shows the needs to have the read-only page written. The stack needs to grow. It's attending to find an extra page. The third and fourth are irrecoverable. So the last one, the working set concept is important and heavily used in Windows paging systems, and the size of it is not constant. Therefore, its disadvantage is reduced. In addition, it is assigned to the process with an amount of the main memory, hence the pages are contained in the working set that are present in the main memory. Windows uses local clock algorithms. So now, Windows divide list of page into 4. The first one, free page are those clean page which are not even associated with some. The zero page list is the list of zero out pages if it's needed. The modified page list is the last of the 30 pages. Standby is a list of clean pages and associated with a process, whereas free pages, those pages are handled by working set manager and some other daemon threads like swapper threads, map page write and modify page writer process. So this is the figure above shown the 4 lists that divide by Windows. Next, Linux operating system. It focused on low overhead and simplicity. Therefore, it had many problems and primitives, and especially under heavy load. Linux uses a demand page system with no pre-paging. After that, Linux used NRU algorithm for page replacement, but due to the various shortcomings of the algorithm, they changed the edit and implemented an approximate least recently used. The aging to effect LRU, least recently used, is brought about by increasing the age of a page by a constant when the page is found to be referenced during a scan and decrease exponentially as divided by 2. So now, Linus divide virtual page into 4 lists. To separate the page which were chosen for evictions, the inactive 30 list was made. Normally the active page are on the list 1. If some of the page are not active, then their age decreases and goes down to 0, which shows it is a candidate for eviction. Such pages are moved from list 1 to list 2. The inactive list size was made dynamic. Now the system itself will decide how many inactive pages it should keep in the memory given the particular situation. The unifications of the buffer cache and page cache has been completed in the Linux. Another optimizations present in the Linux kernel is that they now recognize continuous I/O. For example, they now decrease the priority of the page behind and so that the page becomes a candidate for evictions sooner. The page statement in Linux is evictions once a second and frees memory if enough is not available. So now conclusions. The two systems have originated in different backgrounds, that Windows in commercial settings and Linux in hacker settings. They are pretty modern and theoretical concepts and suitable for production environments. They have many similarities and differences. Windows is developed with strong monetary motivations, has gone through more effort and though in its design and development. The design decisions made at various levels are tended to be conducive to better performance. For Linux, the decision taken often favoring simplicity against performance. Therefore, Windows has developed into sophisticated, complex code, whereas Unix is simple and elegant. Windows has more features in results, however, it is difficult to be maintained and improved from the views of developers, while Unix has less features but it's easier to maintain and develop. For the end user to give better performance, Windows is likely to suit in these situations, although it crashes occasionally. There are more research and development is required for the open source system, and there is a good scope for it. Its documentation on open source operating system like FreeBSD and Linux is lacking, especially ones which are comprehensive and up to date. It seems that as soon as some documentation is completed, the fast development of this operating system rendered them out of date. The rate of development of these open source operating systems, which are maintained by hundreds and thousands of hackers around the world, it may well be expected that in the future, this operating system become at par or becomes better than the commercial offerings.